So this is a standard clinical um, brain MRI that we're going to do the measurements for the canine cognitive dysfunction study on. Um, this is standard sagittal plane T2 weighted sequence, and this is a transverse plane T2 weighted sequence here. And we're going to start off and do some measurements on these two. So to evaluate the interthalamic adhesion height, we're going to use the sagittal plane sequence here, just because it highlights the entire extent of the interthalamic adhesion. And actually, this is an example where we've got a slight obliquity in the sliced placement. So we're getting a little bit of hazy, ill-defined attenuation dorsally, sorry, intensity dorsally, which is just a slight catch of the adjacent thalamus. But we can see the dorsal aspect of the adhesion pretty well. So I'm happy to continue with this case. So we have, we just use our length measurement and we can just scroll up really high. And I really like these um, boxes that pop up on a Cyrix, but you can use any imaging processing system. And we're just going to measure our height and record at 7.47 millimeters here. We're then going to switch over to the transverse plane sequence, and we're going to make sure the transverse plane lies directly over the interthalamic adhesion height at this level. And we're going to take a measurement of the cranial height. So we're going to go basically from the sphenoid bone or dorsally. And remember, going to have a dorsal sagittal sinus dorsally, but I want to go from bone to bone. So we're going to go up and we're going to basically look at where our two hemispheres end, and we're going to place our measurement between the two aspects of the cranial cavity. So here we are, 4.54 centimeters or 45.4 millimeters for that measurement. The next measurement we're going to do is actually the hippocampal height measurement. And to do that, we're just going to scroll back. We're going to use the criteria provided in nice, the really nice paper that was written on hippocampal height by Giardini and others. And we're going to scroll back to the level of the mesencephalon at this level here. And we want to be at the level of the mesencephalon when we're seeing the rostral colliculi beautifully, which we can see in these two little areas here. And we can see the mesencephalic aqueduct really nicely. And we're going to measure our hippocampal formation on either side at this level. So what we do is we're going to go from the edge of the lateral ventricle and the hippocampal formation and come in to the medial aspect here. And we're going to measure them at the maximal diameter of those formations and take those two measurements. And additionally, at this level, we're going to take a measurement of cranial height. So again, we're going to go between the two sort of dorsal gyri there and come down and measure to the base of the cranium here and get that measurement as well. And so we have, after these measurements, we'll have two cranial height measurements, the hippocampal measurements and the interthalamic adhesion measurements. The final measurement we'd like to do is the dorsal is within the dorsal plane, and this is just to get an idea of the shape of the calvarium. And so we're going to do a length measurement from the olfactory bulbs caudally right to just exactly the longitudinal extremities of the calvarium, and then also a width measurement at this same level. So in order to get that slice, it basically scrolled to get the absolute maximal longitudinal length, and that was the slice we choose. And then we take those two measurements to obtain those at that level. Now, another, if you have available the T1MP RAGE, this is another sequence that we can do the measurements on, and it would be fantastic to have both sets. So either the 2D sequences and, if available, the T1 3D sequence. So this is a standard T1 MP range. This is 1 mm cubed, and it allows us to reconstruct in 3 planes in an isovolumetric manner. What's nice about this is that I can really realign the slices to be in a very standardized fashion, so it allows for much more, slightly more accurate measurements to be made, because we have everything perfectly aligned, and that's very standardized across sequences. So what we're going to do is just start off and make sure we have the correct alignment. So to do that, we're going to alter our longitudinal measurement to be basically roughly perpendicular, our transverse slice to be perpendicular to the base of the cranium and the sphenoid bone here. And then we're going to come up to our inthalamic adhesion here. And so this basically slices the brain kind of along its sort of dorsal, really slices it kind of along its length really nicely. And from that, we can do our inthalamic adhesion height measurement on our sagittal plane sequence, and we can do our height measurement on our transverse plane sequence really nicely. And then we're going to go up to here. And then we're going to scroll caudally, and we're going to go find that positioning for the measurements of the hippocampal formation. And so we're going to come back until we see our rostral colliculi really nicely and our mesencephalic aqueduct really nicely. So it's just getting here, just find a nice well-defined slice. We're going to see the margins, and then we take our hippocampal measurements at this level as well. I could have used the much more higher resolution sequences from the 3 Tesla we have, but I wanted to do the measurements on a lower field scanner, which is a bit more relevant for most clinical scans going on. Okay, so then in order to get the final length measurements of the brain, we're actually going to tilt the axis so that it runs from the maximal extent of the cranium, so from the caudal aspect of the cerebellum at this level, right the way to the olfactory bulb at this level. So we're going to just take our length measurement, let's scroll to make sure we're going to get the maximal length of our occipital bone to our olfactory bulbs here. And we're just going to take that length measurement and then our width measurement here. There we go. Great. And so those are the total measurements that we'll be doing on these brain scans. And thank you very much for assisting us with this project.